Good day, I'm Miss Jen Benitez. I will discuss to you about intermolecular forces. Let's start with the etymology of the word intermolecular forces. Derived from the word inter. Class, what do you mean by inter? Yes, very good. Inter defined as between. And molecular, derived from the root word molecule, consists of and one class. Yes, very good. It consists of two or more atoms. So based on that, who can define the word intermolecular forces? Yes, very good. Intermolecular forces, these are the attractive forces that exist between the molecules. It is the result of attraction of positively and negatively charged region of a separate molecule. Let's proceed to different types of intermolecular forces. The first one is ion dipole. Ion dipole, it is the attractive forces between the ion and the polar molecule. Okay, let's have a recall. Ion, what is ion, class? Yes, very good. Ion, it is an element with a charge. It's either positively and negatively charged. And last time we discussed about the polarity of the molecule. In the polar molecule, the electrons are unevenly distributed because some elements are more electronegativity than others. Let's have an example. Sodium with positive charge given as an ion. Assume it will be attached to the water molecule. So one most popular polar molecule. So we need to draw it in Lewis structure. The water molecule has two touch of hydrogen atom to the oxygen atom. So then we need to put the charges of each element in a molecule. If an atom with higher electronegativity, it has negative charge. And then if an atom has lower electronegativity, it has positive charge. So class, to the use of your periodic table, we can identify the electronegativity of an atom. Okay, class, what is the electronegativity of oxygen? This, very good. It is 3.4. How about hydrogen? What is the electronegativity of hydrogen? Very good, it's 2.2. So, definitely, the oxygen has negative charge because it has the higher electronegativity, and hydrogen has positive charge. The positive charge of sodium is attractive to the negative charge of oxygen, and then the forces will be formed. It's what we call ion dipole. The next one, hydrogen bonding. It is the attractive force between the hydrogen atom in the polar bond and the electronegative of oxygen, fluorine, and nitrogen. So if the hydrogen bonding will be formed between the hydrogen and oxygen, hydrogen and fluorine, and hydrogen and oxygen. So the hydrogen bonding in the water molecule is particularly strong. So let's have an example. Example of hydrogen bonding. So let's draw the structure of water molecule. So the hydrogen has the positive charge because it has a lower electronegativity than the oxygen. The oxygen has the negative charge, the positive, negative, positive, and then negative. So the hydrogen bonding will be formed because of oxygen of the one molecule is attractive to the hydrogen of another molecule. So this will what we called hydrogen bonding. Then the positive charge, and then the positive charge of one molecule is attracted to another negative charge of another molecule. So the bond, oxygen and hydrogen is what we call hydrogen bonding. The third one is dipole-dipole intermolecular forces. It is the attractive forces between the polar molecules. So let's have an example. So example, hydrogen sulfide. Let's assume we have two molecules of hydrogen sulfide. Hydrogen sulfide and then so again we need to know the electronegativity of each element in the molecules. So what is the electronegativity of sulfur? It's 2.4. And what is the electronegativity of hydrogen class? It's 2.2. So what element have the higher electronegativity? So the sulfur, right? So it has the negative charge, and then the hydrogen has the positive charge. It's positive, then negative. Hydrogen sulfide considers a polar molecule because the structure is asymmetrical arranged. It's one the property of the polar molecule. So the sulfur of first molecule is attractive to the hydrogen of the next molecule, another molecule, and then we call that dipole-dipole interaction. The London dispersion. The London dispersion, it is the attractive forces between the non-polar molecule. So again, class, what is a non-polar molecule? Yes, very good. In the non-polar molecule, electrons are equally distributed, and then they have or symmetrical arranged around the central atom. So, for example, is methane. Again, we need to draw the molecular structure of methane. Carbon, hydrogen, hydrogen, hydrogen. Carbon, hydrogen, hydrogen, hydrogen. In the London dispersion, the force of attraction results at temporary dipole movements induced in ordinary nonpolar molecules.